Awesome. So let me just copy 0, 10, 11, 12, and 18, and 515, 585, 655, 725, and 1010. Okay. So then we go to the graphing calculator and stats. We edit and go back to the top and clear and clear and enter these 5 ordered pairs: 0, 10, 11, 12, and 18. And the other variable, the y variable, now 515 and 585 and 655 and 725 and last one 1010. And all we need to do is go to stats and tests, calculations, and choose linear regression, which is number 4. And yes, list L1, list L2. The feature that I like here is the fact that it allows me to store the linear regression line in whatever I want. So go to variables,
y variable. Still sharing your notes. I'm with you all the way up to sharing the notes.
I'm sorry. So go to stats and edit. So go to the top and highlight the list and then clear, and it would automatically clear the whole list. And then we enter in list L1 0, 10, 11, 12, 18. Let me know when you have this. And then in list L2, we enter 5.15, 5.85, 6.55, 7.25, and 10.1. And then we go to stats and calculations, and this is number 4. So the list L1 contains the x variable, list L2 contains the y variable. You don't need a frequency list, but under store regression equation in, go to variables, y variables, and function. And I pick function y1. So automatically you don't have to type it in. That's the beauty of this. And then you click on calculate. It will give you the regression line, which has the slope ax. The slope is this, and the y-intercept is this. You do not need the coefficient of regression. And when you go to y equals, you will see this entered already. That's the beauty of this feature. You don't have to type it in, and look how many decimal digits it uses. And now the problem, I think, was asking us to predict the minimum hourly wage in 2020 and 2025. But remember, you have to read this. It's the number of years since 1997. So you have to subtract 1997 from 2020 and then from 2025, and you plug in that number in y equals. And you automatically get the y value. Okay, so which one would you like to work on? It doesn't matter, we can do both. So 2020 minus 1997 is 23 years. And this is 28 years. So when we enter 23, second and table, 23, 28, and so on and so forth. Now, remember our comment from last time. As you look at the list, everything happens between 0 and 18. I plugged in 23 and I plugged in 28. This is way out of the so-called range of values, not the range of the function, because it's a function here of 2 variables, so I'm not talking about the range. We will talk about the domain of functions of several variables in a minute. But 23 and 28 is out of this, and I caution you that you really have to say, I will have an idea for 23 and for 28 as long as you guarantee that the model is still the same. Okay? If you can't guarantee that the model stays the same, the prediction for 23 years and 28 years means nothing. Okay? Okay. Is this okay, Kirsten? Sorry.
Yeah, no, I think I know exactly what my problem was. For some reason, I had all the zeros in L3 and L4, and I was getting these random numbers that were not matching everything else.
Okay.
Once I cleared everything and
Good.
was able to put those numbers in fresh, I got the same thing that you did.
And
so
that teaches me now one thing, and thank you so much for bringing that up. That moving forward, I will record on this device. Every time I show something like this, like a technique from the beginning till the end, not when I plug in a function and evaluate for 5, because that's not needed. But moving forward, I will do this. And I have other classes in which I show a technique. So for example, there is something called Newton's method, which my students would have benefited if I had recorded that. I mean, I can make a recording and post it anyway, after the fact. But thank you so much for bringing that up.
All right, thank you.
Thank you. Other questions for me? Anything else you would like to work on? Anything else? Okay, so we'll go back to chapter 6. And we know this is functions of several variables. Functions of several variables. So we're looking now at 3 sections, 6.1, 6.2, and 6.3. So first of all, let's talk about 6.1. In 6.1, this is just an introduction, basically, to functions of several variables. How will a function of several variables look like? Something like this. There are 3 variables here. This is the function, one variable. This is the x, an independent variable, and this is another independent variable, right? So it will look something like, let's say, 3x squared y plus 4xy minus 3y cubed. So this is an example of a function of 2 variables. If I am told, evaluate this function for 1, 2, I know what I have to do. I only have to replace x by 1 and y by 2 all the way and calculate. So f of 1, 2 will be 3 times 1 squared, which is 1, times 2 plus 4 times 1 times 2 minus 3 times 2 cubed, which is 8, and I perform the calculations, and that's it. Okay, how will a function of 3 variables look like? Well, something like this. X, Y, Z, of 3 independent variables, and this is the 4th one, basically, right? And the same thing, 4xy plus 2yz cubed plus 10x squared. So now we have a function of 3 variables. Okay, so I'm going to share my screen, and let's take a look at how we evaluate. So back to 6.1. That's all we need to do in this first section, just a warm-up. And also I was, did I have this? I think I had this ready for you. I wanted to show you how a function, no, it just disappeared, I think. Yeah, okay, never mind. I just wanted to show you how it looks. It's a surface, a function of 2 variables, x and y. It's a surface. Let me see if I can get to it. So here are examples of surfaces, 3-dimensional surfaces. So here's one. See? So z is basically the function, x and y, z or f, same thing, right? And x and y are the independent variables. So this is an example of how a function like that would look like, or like this. Okay? So we're going to look at how to evaluate and how to find domain for these functions. That's it. So I'm going to get to examples in a moment. These are all sorts of examples. Okay, so here in this first section, we are evaluating. We already illustrated that. If you'd like to pick any other problem, we will. But I would like to look at these problems with finding domains. So let me know if you'd like to pick anything, or we should pick anything from evaluating. Any preference? Well, I like to look at, let's say, at least one, let's say like 5, because it has natural log and we are asked to find, we don't have to evaluate for all of them, right? So let's choose this function with in x and y, and let's find either f of e2, e comma 2, e squared comma 4, or any of these, just as a warm-up. So f of x and y is natural log x plus y cubed. Which ordered pair would you like to plug in?
Can I do the e to the third?
This one, very good. Okay, so e to the third comma 5. Excellent. So all of them are the same, right? So all I have to do is replace x by e to the third and replace y by 5 to the third, by 5 and raise it to the third power. So remember what we do. We talked about this property, the power property, right? So 3 goes in front as a factor, and we all remember that natural log e equals
1.
Perfect. So plus 5 to the third, which is 125, plus 3 is 128. So the value of this function when x is e to the third and y is 5 is 128. So assuming, you can stop me anytime, assuming you're not interested in evaluating, I would like to continue with domain. But if you do want to evaluate another, let me know.
Can we do number 12?
Yes. So let's start with the domain for number 12. Excellent. So in 12, h of x comma y is x e to the square root of y. Perfect. So we're looking at the function. Now, first of all, I'm going to look at x. X appears only here. Well, x has no restriction. It's not under a square root. It's not in a log. It's not in the denominator. I have no restrictions on x. Now I'm going to look at the other piece, because the other piece has e to the square root of y. Are there any restrictions for y? Anyone? Any restrictions for y?
It has to be greater than or equal to 0.
Brilliant. Thank you. So then the domain of this function is any ordered pair x comma y such as or having the property such as or having the property dot dot dot. What is the property? That y is greater than or equal to 0 and any x. If I have no restriction for x, it means it's guaranteed that all these pairs have to have, or the pairs have to have y greater than or equal to 0, any x. There is no restriction on x. If x is not mentioned, x is free. Good. I just saw Nick's chat. Thank you. Good. So let's go back. I would like to choose 11. In 11, we have f of x comma y, the square root of y minus 3x. You already told me, I'm not going to ask you again. So you already said this. If you said y greater than or equal to 0 for this, you're going to say y minus 3x greater than or equal to 0. And this cannot be solved. You could just simply write greater than or equal to 3x. We cannot solve that, right? So then the domain for this function will be any ordered pair, x comma y, having the property this. So I can only pick numbers in such a way that this value is at least 3 times this value. So an example would be if x is 2, 2 times 3 is 6, so y has to be greater than or equal to 6. If I pick x equals 15, then I have to have y at least greater than or equal to 45. So that's how I determine my ordered pairs. Good. Any questions, or can we work on a word problem here?
Would we do number 10?
Yes. So it's the same thing. So 10 is the same. So we have g of x comma y. This is natural log of x squared minus y. So you know that in log, I cannot plug in anything else but positive numbers, not even 0. Only positive. So then the domain will be written in exactly the same way. Is made of any ordered pair having the property this. Either x squared greater than y, or y less than whatever, or just this. It doesn't matter how you write it. But that's the only restriction we have for this function, that x squared minus y has to be greater than or equal to 0. Okay, I like to just illustrate with a word problem. Functions of several variables. What about the wind speed of a tornado?
Nick has to do number 14.
He wants number 14. Is he muted? Nick, are you on Bluetooth?